Righto, so to finish this up, I need to find when x is equal to 1 on 2e. So f of 1 on 2e is equal to, now it was x log e of 2x, so that's 1 on 2e multiplied by log e of 2 times 1 on 2e, which is just 1 on e. And we can simplify this here a bit, so that's 1 on 2e multiplied by log e of e to the power of negative 1. And log e of e to the power of negative 1 will just be negative 1. The log e and e cancel each other out. So we're just left with negative 1 over 2e. And this gives us the coordinates then of 1 on 2e and negative 1 on 2e. That's quite nice. Anyway, I'll pause here again and get the next question set up. Hopefully we'll get through this one in this video. Righto, so the last question I'm going to do on this, the curve with equation y equals x cubed plus ax squared plus bx plus c passes through the point 0, 5 and has a stationary point at 2, 7. Find the values of a, b and c. So the first thing I'm going to do is I'm going to sub in the 0, 5. Okay, I know that when x equals 0, y equals 5. So that means y equals, sorry, I don't even need to write y equals. I should just write 5 equals. Now that's 0 cubed, which is 0, and a times 0 squared, which is 0, and b times 0, which is 0, and it's just c. So that's one of our answers right there. I'm going to rewrite the equation now. So y equals x cubed plus ax squared plus bx plus 5. Now, the next thing I'm going to do, I know it has a stationary point at 2, 7. So I can differentiate this. So dy dx equals 3x squared plus 2ax plus b. And I know that that's the point 2. And I know that at that point the gradient must be 0. So 0 is equal to 3 times 2 squared plus 2a times 2 plus b. And so that means that 0 equals, now 2 squared is 4 times 3 is 12 plus 4a plus b. I might even rearrange that to say that 4a plus b equals negative 12. And I'll call that equation 1. Now, I'm also going to use the point 27 because I know that that is a point on this curve, so I can just sub those two values in as well. Okay, so 7 equals, and it's 2 cubed plus a times 2 squared plus b times 2 plus c, which was 5. I'm going to just take away the 5 right away, so make things a little bit easier later on. 2 equals 8 plus 4a plus 2b. Now I'm going to take away the 8 now, so negative 6 equals 4a plus 2b. And I'm going to call that equation 2. Now from here, I think that we should be able to cancel out the a using elimination. So I'm going to do equation 1 minus equation 2, I guess. Oh no, I'll do equation 2 minus 1. That seems nicer. So equation 2 minus equation 1. Negative 6 minus negative 12 becomes positive 6. 4a minus 4a is nothing, and 2b minus b is just b. So b equals 6, which we can then sub in to one of the equations. I'm just going to sub it into 1. And so we get 4a plus 6 equals negative 12. I can take away 6 on both sides to get 4a equals negative 18, and then divide by 4 to get a equals negative 18 on 4, which is the same as negative 9 on 2. Anyway, I think that's about all I need to do there, so leave it there. Finally got the timing right on this video, but yeah, that's all for this particular exercise, so we'll pick up with the next one. Anyway, see you next time.